All right, so we have a fun one today. We're going to do a lot of demos and we're going to feature a lot of nerd knobs. So Andre, I think it's probably pretty universal when most people think about a VPN, they think it's slow. It's really frustrating. I remember vividly getting super annoyed having to log into this clunky old Citrix VPN. So I still have a little like pent up rage about that. But what does slow really mean?
Yeah, that's the problem, right? Like, first off, slow is very subjective. It's not easy for a lot of users to go and dig in and diagnose that.
Yeah.
So I'm a network guy. I've been doing this for 25 years. And I can tell you it's typically the network that get blamed first when things are slow, and it's been sort of our job almost to prove our innocence. So we've gotten really good at that as network engineers. But slow can be a lot of things. It could be your local Wi-Fi, it can be the ISP, it can be the server, it can be the
Mhm.
cloud provider, it can be the ways the stars are aligned. And so it's a bunch of stuff. And I think as network engineers in general, we've learned a lot of lessons. And at Border Zero, we've taken a lot of that and focused really on removing that ambiguity, and also, help you identify if it's slow, and if so, maybe where the root cause lies.
Yeah, I mean, I think that's so important. I feel like our kind of North Star is removing friction and slow is friction. So yeah, I guess let's talk about, what we've kind of put in place to help people do those diagnostics themselves. Let's say that I feel like, or someone on my team feels like, the VPN is really slow. Where would I start?
Yeah, so maybe you're the IT administrator, you get the hey, someone tells you the internet or VPN feels slow or whatever. So the first step is to basically let's try and quantify that. Like, what is slow? Like, is it within a bunch of parameters or not? So it could be that you're expecting a gig, but you're only getting a megabit or something like that. So
Mhm.
the first thing is to quantify that. So to do that, to make it really easy, is if we have a built-in speed test in our each of our connectors, which is essentially the VPN servers, that you can browse to. And so let me just share my screen. So as the IT administrator, you would just tell your user, hey, go to this URL, which is essentially HTTP colon slash slash the name of your connector, port 4242. And again, we were talking about nerd jobs. So for those who are real nerds, they will recognize some significance with those port numbers. But as you can see, it will load a quick speed test, and you can just start that. And what happens here is essentially the browser will download a few files of different sizes. It will upload a few files of various sizes, and that will give the user and the administrator a sense of, hey, what is the performance of the VPN directly between the client and the Border Zero connector, the VPN server, essentially. And now we can actually quantify, hey, what is the speed, and is this as expected or not?
Mhm. Mhm.
So it is the first step. Like, isolate the speed, measure the speed directly between the client and the connector, and determine whether that's within the parameters expected or not.
Okay, so let's say, for the sake of argument, that we have determined that it is actually slow. Like we've done that speed check. We're like, nope, it's definitely something is laggy, something is slow. What are some of the reasons that could be causing that? And how do we determine next steps for troubleshooting?
Yeah. So if that happens, and it does happen, it can have a whole bunch of reasons, like I said. So we got to remember, let's say you are at home on, let's say, something like Comcast or AT&T, and your VPN connector is in AWS or your data center. Now, generally, to get between your client and your connector, you have to go over your Wi-Fi and then your ISP, and then your ISP has an ISP, and then goes to the ISP of your data center, and then you end up in the data center. So you can see there's a whole bunch of paths in the middle, and
Mhm.
along each of these paths, inevitably things happen. And it could be
Mhm.
fiber cuts, it could be congestion, it could be bad capacity management, it could be temporary spikes due to DDoS attacks that are happening in the region.
Mhm.
So there's a bunch of reasons. And we don't want to bother you with all the details, but generally I summarize them as bad internet weather events.
Mhm.
Like, this is bad weather in that region, in that ISP or whatever. Shit happens, we got to live with that,
Yeah.
right? Okay, well, what do we do? Like, it's not always within your control. Well, the good thing is that most machines have IPv4, IPv6, and also a path over what we call the relay connection, which is essentially WireGuard over HTTPS, which goes through a any-casted network with lots of middle mile optimization and globally any-casted stuff. But the real point there is that's another path that we provide.
Mhm.
So let me actually pull up my terminal here, and I'll show you the first debug command that I wanted to show you here. So here I typed in border zero node debug peers, and it shows me all the peers, all the VPN peers that I have. These are WireGuard peers. So we get pretty technical and deep here. But there's a wall of text, but I'll just highlight here this one, for example. And so here you can see that I have a peer, and there's 3 lines for this particular peer. And this will show me that, hey, this peer has an IPv4 address, it has an IPv6 address, and it has this what we call UDP-R, UDP relay address, which is this WireGuard over HTTPS. And so there's 3 ways for my computer to talk to this connector. Now, chances are that each of these paths go over different routers, different ISPs even, with, especially with the relay. And so we have some built-in resiliency and redundancy. And so what we do is, hey, this connector has 3 possible paths to get there. Let's go and measure that. Let's see which one is the best. Which one do I take, right? So
Mhm.
go over V4, IPv6, or the relay connection. So what we do is send every few seconds little probes and say, hey, over UDP IPv4, how long does it take to talk to the connector? And it will get back a number, like we call that the RTT, the round trip time. So maybe
Mhm.
10 milliseconds or whatever that number is. You get back a loss number, packet loss in percentage, which shows how many packets got lost along the way. Then we give it a score. And based on that score, we can determine, hey, should I use IPv4? Should I use IPv6? Or should I use the relay? And by the way, you can see some of these connectors have way more lines because sometimes people have multiple IPv4 connections or multiple IPv6 IP addresses. And we'll try all of them. And so what's really cool is that at the end, we can constantly reevaluate, hey, which path is the best? And so maybe we'll swap from IPv4 to IPv6 if the IPv4 connection is measuring packet loss or over the relay. And what's really cool is that this switching back and forth is all transparent to the user. It doesn't blip any of your connections or something like that. And so what we've built here is essentially a responsive VPN that takes into account all the various paths that you have, not just one. Like most VPNs is like, okay, I need to connect to that thing and I'll do it. And if it doesn't work, it's like, well, obviously you have packet loss. And we're like, no, we don't have to stop there. I actually have 2 or 3 or even more other paths. Let's go measure them and let's go respond in real time to, which path I should take. And, I think I'm obviously very passionate about this. But this allows us to essentially route around these bad internet weather events whenever possible.
It's very cool. I feel like the people who are going to appreciate this are the people who like jot down their miles per gallon in a little notebook. Like it feels like that's your audience. But anyway, awesome. So I think, from here I'd love to talk about some of the other debug commands that you've kind of built in. So obviously, those power users are going to be hungry for more. Like what else have you got for them?
Yeah, so what we can do, let's see what else we have here under this border zero node debug command. So we can see there's a bunch of other stuff in here, like DNS or stats or logs or WireGuard settings. And I won't bore you with all of them, but yeah, if there are nerds on here, some of these commands are pretty useful. For fun, I can do border zero node debug DNS here, for example. So we just release DNS features as well, and that allows you to configure which DNS servers your VPN clients should use, which allows you to use like internal DNS names and private DNS names. And so once you configure that, you basically say, oh, this is the DNS server all my clients should use. That gets sent pushed to the clients. And you may want to know, okay, is that being pushed? Has it been propagated? Has it been properly picked up? So this command shows you the configured resolvers.
Mhm.
It also shows you maybe any more specific domains that need to go to different resolvers. It also shows you the original DNS servers that we will repair it back to when you shut down the VPN, etc. So these are the kinds of interesting debug commands that we have available to allow you to see some of the internal configuration of the VPNs.
Very cool. All right, so let's play devil's advocate here. I have tried to troubleshoot. I've done, all of these checks and diagnostics and whatever, and I'm still stuck. What have we done to make it easier for people when they need to talk to support?
Yeah. Unfortunately, sometimes things just don't work as expected. And like I said, it could be have a number of reasons. It could be the network, it could be the computer, it could be our software. And so it's very important to us to also make that process as easy as possible. So we have a whole bunch of debug commands that I just showed you a little bit of. But what happens if, Susie in accounting has like, hey, the VPN is slow or it doesn't work? Then typically she will go to the IT person, and then the IT person may open a ticket with us, and is in very good hands with the support team. But what we want to prevent is to go back to Susie every, half an hour. Say, hey, can you now execute this command? Can you now execute this command? Right? And because she just wants to get her job done, and we're very well aware of that. So what we've done is collect or create this other command called border zero support collect, and that will collect all of the border zero support information. And essentially executes a whole bunch of those debug commands that I just showed you. There's quite a few more invisible ones as well. It also gets like, oh, well, your network interfaces. It will measure the latency and connectivity to some of the critical API servers that are needed, the relay services, a whole bunch of stuff. And we all put that in one file, and you can, send that information to a file. You can even say, hey, upload it and automatically to our systems, and then the support team will automatically get an email with all that information. And the point there is mostly, Susie, just execute this once, and then you can move on. That will give us all the information that we probably need to figure out and identify where the root cause lies, and then hopefully fix it as soon as possible.
Yeah, awesome. So it seems like really what we've done is build in a lot of these nerd knobs for power users who maybe are curious, people who really want to try to diagnose problems on their own, and then really shorten that loop. When something isn't able to be solved internally, so that that cycle with support is hopefully a lot quicker.
Yeah, less friction for users and then better information for the support team so that we just can solve this as fast as possible for everyone involved.
Awesome. All right. So what's the bottom line?
Yeah, what's the bottom line? Well, I guess the bottom line is, as a network engineer, I think in the end, the network often gets blamed, and networking is hard because of all of the dependencies, and so many external factors. And like I mentioned, the internet is a collection of networks, and they all have their own domains, owners, administrators. They make their own decisions. And if you try and make a VPN connection from one side of the world to the other side of the world, you're typically passing to two, three, four, five different networks, five different domains or providers. And it's not always easy to troubleshoot that. But the good news is that is exactly what most of our team are really passionate about. And like we built companies that did this in the past or worked at companies that did this in the past. And what we've done here is actually codify a lot of those lessons learned either into debug commands or, as you saw, even automatically try and respond to those signals from the network and basically route around it. And I think it's like one of those hidden things that we've done really well and probably don't talk about enough. And so hopefully this particular video gives you some more insight into the nerd knobs and some of the magic that we do under the covers.
Awesome.